Morning, everyone. We're going to do lesson 6 today, Beyond the Unit Circle. So recall that defining the cosine and sine functions in section 2.2, we assigned to each angle a position on the unit circle. Here we want to broaden the idea of it that includes not only the unit circle, meaning radius 1, but beyond that. So if we look, and this was our unit circle here, we have x, y, and our point being on that unit circle. But let's say we extend that radius, what happens then? Okay. So what we want to see is that when we were doing the unit circle, we had x comma y, right, for our point of our special right. We use the special right triangles mostly. But if you look and we went beyond the unit circle and created our right triangle here, what do you guys see? I see that this is proportional, right? These two triangles are similar. So how can we define that? Well, first of all, if we have it with a right triangle, the radius, the hypotenuse, equals the square root of x squared plus y squared. So almost like our Pythagorean theorem, right? And then if we go beyond the unit circle though, so instead of our x comma y being cosine comma sine, because don't forget that we were doing opposite over hypotenuse, adjacent over hypotenuse, and our hypotenuse was the value of 1 for a unit circle. We can do that in terms of radius. So sine is our y value over our radius. Cosine is our x value over our radius. Tangent is y over x. Cosecant is radius over y. Secant is radius over x, and cotangent is x over y. The other thing that we can get, especially from these two, these two, is if I were to solve for y here, I would get that y equals radius times sine theta. So this will come into play later, where we can also get the x value by saying radius times cosine. So those are a few ways that we can manipulate the equation to work for us. Note that in the case of the unit circle, we have r equals square root of x squared plus y squared. But of course, that's equaling 1 in our definition. So let's do some examples here. Suppose the terminal side of angle theta, when plotted in standard position, contains the point Q. So we know the radius is a 1, 4 comma negative 2. Find cosine and sine. All right, so let's just draw this so we can see it. So 4, negative 2. So we're in the fourth quadrant. So I say I have 4, negative 2. So we need to find r. So r equals the square root. Let's see, 4 squared is 16 plus negative 2 squared is 4. So that means our radius is the square root of 20. Let's make sure that we simplify this all the way. So r equals 2 square root of 5. And now we want to find cosine and sine. So cosine of theta equals x, and our x value is 4 over our radius, which is 2 square root of 5. Now we're going to simplify this more and rationalize the denominator too. So we get 2 over the square root of 5. Get rid of that square root in the denominator. We end up with 2 square root of 5 over 5. Next we have sine theta, which is our y value, which is negative 2, over r is 2 square root of 5. Simplify this, 1 over negative 1 over square root of 5. Rationalize the denominator, so negative square root of 5 over 5. Now, we did not do section 1.3 yet. We will in the future, so let's wait for this question. Let's do some more examples. we're not going to worry about position or particle yet with motion. So let's go down to example 4. So suppose the terminal side of theta, which is plotted in standard position, contains 3, -4. Find the 6 circular function. Okay, so just like we did in our example 1, I'm going to plot this 3, -4. So I know what quadrant it is in. It's quadrant 4. So 3, -4. So we got to find out our R. R equals x squared. So 3 squared is 9 plus y squared. -4 squared is 16. So R equals the square root of 25, which equals 5. Now we're going to write all of our 6 circular functions. We got sine, which is y over r. Cosine is x over r. Almost wrote down where r is. Tangent is y over x. And then for our other 3, of course, we can just do the reciprocal because we know that relationship there. So 5 over -4. Secant goes 5 over 3. And cotangent equals 3 over -4. Okay, what other ways can these questions be asked? Because this is the idea, right? Well, the thing is, you need to be ready for questions that don't say the coordinate, but that just say what quadrant it is. So you have to kind of imagine what would that be. Okay, so let's think about this. Let's suppose theta is in quadrant 4 and with the angle cotangent of -4. So of course, if we think of cotangent of theta, cotangent is x over y. All right, well, let's think of -4 now. -4 is the same thing as -4 over 1. Now, if we think of the 4th quadrant, our x is positive and our y is negative. So in that case, our x is 4 and our y is -1 because we know it's in the 4th quadrant. Okay, because x has to be positive, y has to be negative in the 4th quadrant. So let's figure out our r. R equals the square root x squared, so 4 squared is 16, plus -1 squared is 1. So r equals the square root of 17. That can't be simplified anymore, so that's fine. And the question has us find the 5 remaining. All right, so let's do sine. Sine of theta, that's y, which remember we said y is -1. Let me plot this so you guys remember this. So x is 4, y is -1. So -1 over 17, square root of 17. Let's rationalize that. So it's negative square root of 17 over 17. We have cosine of theta, which is x over r. Rationalize that. 4 square root of 17 over 17. Tangent. Now, yes, we can do our sine and cosine, but remember, tangent is y over x, so -1 over 4. We have cosecant. So it's r over y, or of course negative square root of 17. Secant, which is r over x. And we're done. So that's it for chapter or lesson 6. Just be careful of the wording, what quadrant, and what you want to be negative based on that quadrant.